For problem number 21, our textbook asks us to find the horizontal and vertical asymptotes of the function. And so this is the function that they gave us, f of x is equal to 2x plus 1 all over x squared plus x. Okay. Now, the vertical asymptotes, we'll do that first. Vertical asymptotes occur in the zeros of the denominator. So if I say x squared plus x cannot equal 0, I just need to figure out what makes this thing equal 0. All right? So what we do is we do prime factorization. In other words, I'm going to say x times x plus 1 equals 0. Then I say x cannot equal 0 and x plus 1 cannot equal 0. And so x cannot equal 0 and x cannot equal negative 1. Alright? Now if you do the algebra, if I plug in 0, it makes it equal 0. If I plug in negative 1, it makes it equal negative 1. I mean 0, right? Because this would be like negative 1 squared if I plugged it in here, which is a positive 1, and then this would be negative 1, which equals 0. So that's where my vertical asymptotes occur, is at 0 and 1. So if and I'm going to graph this in a second, but if I have my xy plane, I'm going to have an issue of a vertical asymptote. Sorry, I started the calculator, so it's going to do that now. Yeah, x cannot equal 0, and x cannot equal negative 1. Okay? And so this behavior, the next thing that we want to do is try to determine what the horizontal asymptote is. Now the horizontal asymptote, we're just going to look at a similar function, the end behavior function, because that's what horizontal asymptotes do, is they limit or restrict or converge on a particular value sometimes in these rational functions. And so when we look at end behavior, we really only need to look at the leading terms of the numerator and the denominator. And so really I have 2x over x squared, which really reduces down to 2 over x. Okay? So now think of the end behaviors. If I go and I let this thing equal infinity, I get 2 over infinity. What's that close to? Think of it this way. If I take 2 pizzas and I divide them into infinitely many slices, not 10,000 slices, not 1 million slices, not even 10 trillion slices, but infinitely many slices, how big will each slice be? You guys are doing it? Yeah. It'd be 0. It'd be nothing, right? Because 2 whole pizzas cut into 10 billion slices, you couldn't do it, right? And infinity is way more than 10 billion. So if we look at the end behavior of this, it looks like it's going to approach 0 on the end here and 0 on the end here, right? In other words, the limit of f of x as x approaches infinity looks like it approaches 0. And then over here, if I say the limit of f of x as x approaches negative infinity, again, it looks like it's going to approach 0. So I'm probably going to have a graph. It may, and I don't know off the top of my head, it may kind of do something like this, right? Maybe something like this. and maybe something like this, but it's never going to cross 0 except for in the middle. Or it might be the opposite of that. It might do something like this, and then it might come down like this, and then maybe do something like this, if depending on the leading coefficient, if it's positive or negative. So it might look like that. It might be way off base. I don't know. Let's graph it and see. So sometime today, there it is. So now I'm going to come in here, and let's clear this. So I have the quantity 2x. What was that again? 2x plus 1 divided by, I believe it was x squared plus x. Is that right? I think so. See what I did there?